Started the recording. I had though started the recording, but it was not saved.
Okay, okay. Uh,
No, the welcome note by HY sir could not be recorded. So please continue.
Right. So in fact, my objective is extremely simple that I would like to explain you that how R is actually going to work. And based on that, you have to understand that how you have to write the program in such a way so that R is doing the same thing what you really wanted to have it. So regarding the capabilities of R, although I'm going to talk about at a very elementary level today, but if I talk about the capabilities of R, I think mathematical and statistical calculation is the biggest strength of this software, which made it extremely popular. So starting from very basic elementary type of operation till is very high-end calculations, everything is possible in R. And because it's a free software, there are different people around the world which are trying to contribute different types of algorithm regularly, continuously. So the R gives you an edge over over the other software that without spending even a single penny, you can use the latest algorithms and all other things. Right. So today I am going to talk about very elementary operations in the R software, and what I will be doing that I will try to take the scalars, data vectors, and matrices, and then I will try to take that combination to show you that how the operations are done in the R software. So that is my basic objective in this lecture today. So you know that means I can summarize the entire thing in a very simple way that R can perform all sorts of standard calculation like addition, subtraction, multiplication, division, and etc. Etc. Means everything, whatever you can think, whatever you have learned in your undergraduate, postgraduate programs, different types of algorithm, like a Newton-Raphson, etc., etc. Everything is possible. So, and then R has two uh, options that one, you can write your own program to do some mathematical operation, and some of the standard operations, they have been already actually programmed, and they have been programmed, and we call them as a built-in functions, right? So for example, if you want to find out the maxima or say minima or absolute value, square root, etc. So for that, you already have a built-in program in which you can simply write down here MIN, say minimum, MEX for maximum, SQRT for square root, etc. And R can operate with scalars, data vectors, matrices, everything. So now we are going to consider here different types of computation. So first I will try to take the computation in which we are simply trying to add the use the scalars. Means all the operations involving only scalars and then scalars and data vectors and then data vectors only. After that, I will come to the matrix part. So means initial part is extremely simple. This is just for the sake of your information that R works just like a calculator using the rules of mathematics. So if you want to do the addition, the command is simply 2 into 3. Multiplication, the simple command is 2 star 3. Subtraction, the command is 2 minus 3. Division, it is the this division sign 3. For example, if you want to divide 3 by 2, you have to write 3 dash backslash and 2. And beside these things, if you want to take a combination of these operators, then the BODMAS rule is going to be implementable. So BODMAS rule, you know all, right? So yeah, so it is in which you first operate on the brackets, then order, then division, then multiplication, then addition, and then subtraction. The only thing what you have to keep in mind is that in the calculation only this simple bracket is used. This curly bracket or the square bracket, they have got different types of role. So in the brackets operation in the usual mathematics, first this square bracket is open, then curly bracket, and then this parenthesis. But here in this case, everything is controlled only by one symbol, that is your here parenthesis. If I want to give this type of operation, then I have to use like this. Yeah, whatever I want to do, I can do it, right? So Now, for example, if you try to see here, if I try to write down inside 2 plus 3 into 5 plus 5 minus 10, you can see 2 plus 3 is 5, then 5 into 5 is 25, 25 plus 5 is 30, 30 minus 10 is 20. So, and similarly, you can use multiple parentheses also exactly in the same way as you do in the usual mathematics, and you will get here all the all types of outcomes. Now, that was a very elementary part. Now you know that in the R software, when you want to ask the R software to read all the values in the vector, then you have to use this C command. So if I want that this 2, 3, 5, 7, 4 different values, they means all of them have to be considered. Then instead of writing only like inside parentheses 2, 3, 5, and 7, I have to write down here command C. Right, that you take as a rule. So this is called here as a data vector. So whenever we are trying to define a data vector, yeah, you have to be careful that it is not the vector from the vector calculus. It is not the vector from the matrices and vectors, but it is simply the collection of all the points in this way, that first value will be 2, second value will be 3, third is 5, and fourth is 7. That's all. So now I will try to take this as a data vector, and then I will try to now take different types of combination to show you what is really happening and how it actually happens. And in some cases, it is quite different than what is happening in the other software. So if I try to take here this type of data vector 2, 3, 5, 7, and if I try to add here with a scalar, then you can see here that this scalar is being added to every element 2, 3, 5, and 7 like this 2 plus 3, 2 plus 10, 3 plus 10, 5 plus 10, 7 plus 10. And so you get here the value outcome here is 12, 13, 15, 17. So the main thing what you have to keep in mind that when you are trying to take a scalar, you are trying to operate it over a data vector, then each of the elements in the data vector is going to get the same operation with respect to that scalar, right? So, and then, yeah, means you can see here that if you try to execute it on the R console, you will get the same outcome here, right? So this is the way I will try to save my time. But yeah, if you want to understand it, if you want to be more confident, then after the class, you can just try these things. You have all the slides. You simply have to copy and paste the commands in the R console and then try to see, are you getting the same outcome? OK, so once you have understood the addition part, the subtraction part and other things will go in a similar way. So I try to take here the data vector of 4 values 12, 13, 15, 17, and I try to subtract them by 10. So you can see here every number is going to be subtracted by 10. And you get here the outcome here 2, 3, 5, 7. So that is how this subtraction will happen with respect to a scalar and a data vector. And similarly, if you try to take here the multiplication sign, so this multiplication is going to be operated on each of the element 2, 3, 5, and 7, and you will get this outcome without any problem. And similarly, if you try to take the division here, I mean, the division is going to be operated on each of the element inside the data vector here. So this will be 12 divided by 10, 13 divided by 10, 15 divided by 10, 17 divided by 10. So this will be here like this. All right, so that is a very simple way in which this R operates between scalar and data vector. Now I come to another aspect that when we are trying to take two data vectors. So now we have to see what is really happening. And that is the most important, most interesting part actually. So if I try to take here two data vectors like as a 2, 3, 5, 7 and -2, -3, -5 and 8. So you can see here what is happening. It is like this. So if you try to write down here 2, 3, 5, 7 and -2, -3, -5 and here 8. And then you are trying to add both the things. So these numbers are going to be added together. Right, so what is happening? The number at the first position in the first data vector that is going to be added with the first number in the first position in the second data vector. So this will become here 2 plus and then this here minus 2. The second value in the first data vector is going to be added with the second value in the second data vector. Similarly, third and fourth value, they are going to be added in the third and fourth values respectively in the second data vector. So you can see here this will become here 3 plus minus 3, 5 plus minus 5, and here 7 plus 8. So you get here this outcome 0, 0, 0, and 15. Right. So this is how. So you can see here the basic fundamental here is that whatever operation you are going to do, either this is addition, multiplication, division, subtraction, they are going to work element wise, that the respective elements with the respective addresses, they are going to be operated together. So if you have understood this addition sign, then after that there should not be any problem. I simply have to show you here something that now in this cases what is happening. So you can see here in this case in both the data vectors I have taken here uh, equal number of elements, 4 in the first data vector and 4 in the second data vector. Now I try to change it. So now I do it intentionally that in the first data vector I take 4 and in the second data vector I take only 2. So what will happen here? So if I try to use the same methodology here, so it will try to say here 2, 3, 5, 7 from the first data vector, and then it will try to write the second data vector. Now, this second data vector has nothing to do here. So what will happen? That it will try to copy and paste the same thing here, 8 and 9, and then it will try to add it here. So you can see here 2 plus 8 is here 10, 10, 3 plus 9 here is 12, then 5 plus 8 here is 13. Yeah, here it should be here 8. Yeah, please correct it. And then it is here 7 plus 9 is equal to here 16. Right, so this is how it actually works. So you can see here, if the number of elements in the second data vector, they are not equal to the number of elements in the first data vector, then R works in a very different way. Now, when you are trying to do so, then you have two options. The first option is that that in this case, the number of elements in the second data vector, they are going to be the exact multiples of the number of the elements in the first data vector. Or the second option is that this number, this is not exactly going to be the exact multiple of the total number of elements in the first data vector. So here you can see you have here 4 elements and here you have here 2 elements. So this is actually the exact multiple of the total number of elements in the first and second data vector. Now, if this has here 3. So it is not exact multiple. That means earlier it was 2 into 2 is 4, but now 3 into something cannot be equal to 4. So now what will happen? That is the main issue. So if you try to understand here using the same methodology, what will happen here? 2, 3, 5, 7. And then suppose in the second data vector you have here 8, 9, 10. So I will write down here 8, 9, and 10. And now it will try to add here, as we had discussed, that it will try to add here the numbers on the respective positions. So 2 plus 8, 3 plus 9, 5 plus 10. Now, what R is going to do here? So it will, so as we have discussed in this example here, it will try to repeat this thing 8, 9, and here 10. So now this will become here 7 plus 8. But now what to do with this 9 and 10 here, that is not known to us. Right, so what will happen here, that in this case, because there is no number, it is not going to happen that 2, 3, 5, 7, they are going to be repeated here. But the program will say, now I cannot understand, there is some problem, but this problem may be is your choice or you are making a mistake. So what it will try to do, it will try to add here these 3 numbers, like I said, 2 and here 8, which is equal to 10. 3 and 9 here 12, 5 and 10 here 15. Now with this 7, there is nothing here, so it will try to come back to the first element and it will try to add here 7 plus 8 is equal to 15. And then after that, it will give you here a warning message. And the warning message says that here that the longer object length is not a multiple of the shorter object length. Right, so this is trying to say the same thing, that in the second data vector you have here 3 elements, and then in the first data vector you have here only in the 4 elements. So this is not exactly the exact multiple. So that is why it is trying to give you a warning message. Remember one thing, that in the R software, when you are trying to work with the data manipulations, you will have 2 types of messages. One is warning, and say another is error. So warning is something like in the class also many times we try to treat our student that, okay, if you don't do the homework, I will throw you out of the class. So, but usually we don't do it unless until there is some problem. So that is only a warning. Or sometimes you have seen that if you ask me, my mom used to give me the warning message, I think 20 times a day. But fortunately, they never thrown me out of the house. Right. So this is that is the main difference between the warning and error, because error, the program will stop. It will not actually function. It will not operate. It will just stuck there. It will say that first you correct the mistake, and then I will proceed further. So that is the difference between warning and error. So now, once you have understood that how this R is going to work with this thing, after that, in case if you are dealing with the addition, sorry, instead of addition, you are dealing with subtraction, multiplication, division, there should not be any problem as such. Right, may I request you once again all that either you means, because as soon as you try to admit, this control is actually lost. Okay, anyway, so right. So now in case if you try to do the same thing with the subtraction also. So now if you have here 4 elements here in the first and second data vector, you can see here, then once again the operation is going to be element wise. 2 minus this minus 2, 3 minus minus 3, 5 minus minus 5, and 7 minus 8. So that will happen, and then you will get here an outcome here like this one. So that is the same thing which I explained you that is going to happen when you are trying to do this addition. And similarly, if you try to take here only the exact multiple of numbers in the second data vector, definitely they are not the same. So once again, you are going to get the same thing, 12, 13, 15, 17, and then 8 and 9. That is going to be subtracted, but now there are no numbers here. So it will try to write down here 8 and 9. And then if you try to subtract here, you will get here 12 minus 8, 4. And then, and this is a 13. 13 minus 9 here is 4. 15 minus 8 here is 7. And 17 minus 9 here is 8. Right. So that is the screenshot. So you can be confident that if you try to do it, you are going to get the same outcome here also. And now similarly, if you try to take here the number of elements in the second data vector, which are not the exact multiple, then the same story will happen, that this 8, 9, and 10, they are going to be operated over this 12, 13, and 14. And then after this 8, 9, 10 will come here once again, and then it will be, means they have to, so 17 minus 8 will come, but then after what to do with 9 and 10, that is not clear. So it will try to add here 17 minus 8, but then after that it will give you here a warning message that the total number of elements in the second data vector, they are not exactly the multiple of the number of elements in the first data vector. So there is a warning message here. And yeah, so you can see there that the way addition and the way the addition was working, the subtraction is working exactly on the same philosophy. And the same philosophy is continued when you are trying to work with the multiplication. So you can see here, I'm trying to take here 4 element 2, 3, 5, 7 in the first data vector, and minus 2, minus 3, minus 5, and 8 in the second data vector. And if you try to see here, this Now the same thing will happen. 2, 3, 5, and 7. -2, -3, -5, and it has 8. And now it will be multiplication. So that will be 2 into 2. This is here -4. 3 into 3. This is the -9. 5 into 5 is -25. And 7 into 8 is 56. And this is here the outcome. So you can see here this multiplication is also happening position wise. So that the first positions of the two data vectors, they are multiplied, second positions are multiplied, and so on. And now the same thing I can do here, that if I try to take only two elements in the second data vector, then once again the same thing will happen. This 8 and 9, they are going to be multiplied with this 2 and 3. So you get here 2 into 8 and 3 into 9. Then once again it will come and it will try to operate over 5 and 7. So you get here 5 into 8 and 7 into 9, and then you get here this outcome. Right, so you can see here that the way the approach in which it is working, that is the same, right? And similarly, if you try to take an unequal number of elements in the second data vector where the total number of elements are not the exact multiple, then the same thing will happen. This 8, 9, and 10, they are going to be multiplied with the first three elements, 2, 3, and 5. And then after this, you will have here 7. And then it has to be multiplied like this: 2, 3, 5, 7, 8, 9, 10. Now this 8, 9, 10 will repeat again. So this and this are multiply and so on. After this, there are no elements in the first data vector where this the elements in the second data vector can be multiplied. So that is why you get here a warning message and you get here this type of outcome. Right, so that should not be a big deal for you to understand this thing. And just exactly in the same way you have done the this division, similarly you can do the the way you have done the multiplication, exactly in the same way you can do the division also. So if I try to take here 4 elements in the first data vector and 4 elements in the second data vector, then this division will be here like this. 24 means the division is once again going to be division with respect to the positions. So the first positions of the first and second data vectors, they will be divided. Similarly, the second, third, fourth of positions of the first and second data vector, they are going to be divided. So that is going to be here 24 by 3, 20 by 4, 8 by 2, and here 16 by 8. Right, so you get here this outcome. Now the same story continues if you try to take here the exact multiple number of elements in the second data vector. So this is going to be here like this, that this 4 and 2, they are going to be divided in this in the first two elements here, 24 and 20. So it will come with 24 by 4 and 20 by 2. And similarly, after this, 4 and 2 are going to operate on the remaining two elements of this data vector. Right. OK, so this is the way it is going to work. And similarly, if you try to take here the 3 elements in the in the second data vector and 4 elements in the first data vector, then what is going to happen here exactly in the same way: 24, 28, and here 16. And then it will be here divided by here 4, divided by 2, divided by 8, and then once again divided by 4. But now there is no number after this where 2 and 8 can be divided. So it will try to give you the answer 6, 10, 1, 4. And then there is a warning message here. It is trying to say that the total number of elements in the second data vector, it is not the exact multiple of the numbers in the first data vector. Right, so this is the way the divisions are going to happen. So now you can see here, this is not a very difficult thing, the addition, multiplication, division, subtraction with respect to scalar data vectors and their combination. They are going to work in a different way. The only thing is what you have to understand here, which is very different from other software, that when you don't have the exact number of elements in the second data vector, then particularly when you have exact and say non-exact number of elements, then how the R is going to work. This is very important for you to actually understand, because that will help you in writing the right command when you want to do any programming to compute these functions. All right, and you know that without addition, subtraction, multiplication, etc., you cannot do anything in the mathematics. Now, after this thing, I would like to show you that how are you going to calculate the this powers like as 2 cube or like this. So 2 cube can be written like this one. This can be written here as say 2 hat 3. And other alternative is that you try to use here 2 star signs. So 1 star was multiplication and 2 stars will be power operator, means raised to the power of something. Right, so you can see here 2 cube can be written here as 2 hat 3 or 2 double star 3, and you can see here the outcome is the same here. Right. Similarly, if you want to find out the square root. So now in order to find out the square root, you have two options that I will be discussing later on, that there is a function sqrt, you try to use that thing, or you can also write it using the mathematical rules 2 hat 0.5. And similarly, if you try to write down here 2 double star 0.5, and that's the same thing, and 1 upon square root 2, if you want to write that, will be 2 raised power of minus half, so that you can write down here 2 hat minus 0.5. So this is how this power operator are given, and you can use any of the symbol, either hat or double star. Right, so now the way you have understood that that when we are trying to work with the scalars and data vectors with addition, subtraction, multiplication, and division, similar is the operation with the power operator also. So if we try to take here 4 elements, say 2, 3, 5, and 7, then raised to power of here 2, then this raised of power is going over each of the elements. So this will become here 2 square. When it comes here on say 3, it will become say 3 square, then 5 square, and then 7 square. And this is how you can see here the outcome here is 4, 9, 25, and 49. So that is the way it is going to actually work. And similarly, if you have a data vector in the power also, so you can see here if it is like 2, 3, means in the first data vector you have 4 elements, in the second data vector you have 2 elements. So 2 is exact multiple of the 4. So that is why what will happen, this 3, 2, 3, it will come here 2 and here 3, and then once again it will come here 2 and here 3. And you can see here this is the outcome which is given here. Right, okay. So that is how it is actually going to work. And similarly, if you try to take, say, this number of total data vectors in the second data vector, which is not exactly multiple of the total number of elements in the first data vector, then the same thing will, yeah, well, here I'm trying to just show you that instead of taking here this 4 and 2, you can also take it here 6 and 3. So this will happen 2, 3, 4 here, and then 2, 3, 4 there, and you get this outcome here. Right, now, similarly, if you try to take here the number of data values in the second data vector, which are not the exact multiple, then 2 will come here, 3 will come here, 4 will come here. After that, it will start repeating again 2, but then there are no numbers on which the power operators of 3 and 4 can be operated. So that is why it is now giving you a warning message, right? So you can see here it is not a very difficult thing actually, right? Now, there are some built-in functions also. And these built-in, actually, there are lots of built-in functions, but I will try to take here some representative built-in functions so that you can understand that how they are going to work. OK, now when I'm going to tell you, then there is some important understanding also. So I would like to have your attention. Suppose I have here 3 numbers, 1.2, 3.4, and minus 7, 7.8, and I want to find out their maximum. So one option is that you try to write down a entire program for finding out the maximum. Or second option is that you can use here the command here max. So max is something like this, that somebody has written the program to find out the maximum value. So you are simply trying to execute this program here directly. So if you try to think, this is quite equivalent to the fact that as you used to have this operation in a window-based software where you have to say click, click, click. So it is something like there that here that instead of clicking, you have to simply type here max. Right. So if you simply try to write down here 1.2, 3.4 and minus 7.8, it will give you the answer 3.4. Now, I would like to have your attention. In this case, you have not used the C command, right? And but if you try to use here the C command, it is going to give you here the value 3.4. So the first question comes here. In this case, it appears as if whether you use the C command to give the data vector or you simply give it without C command, it is working. So sometimes people misunderstand that in the built-in function, all the things are possible. Right. But on the other hand, if I try to, so I will try to take here one more example here, then you will understand what I'm trying to tell you. So you just wait. Similarly, if you want to find out the minimum, then you are here, then the command here is min minimum. And then I'm trying to give you here both this example where I am using the C command to give my data vector. And here I am now giving the C command. So this is with and without using the C command, but the answer is going to be the same in both the cases. Now I give you one more example. So now with these two examples, it appears that when you are trying to give the input in where there are more than one values, whether you are going to use the C command or not, that is not really going to make much difference. But now I try to give you one more example. Suppose I give here an operator mean. So mean is used for finding out the arithmetic mean. So I simply try to find out the mean of 2, 3, 4. Right. So if you try to find out yourself what will be the value of mean, this will be 2 plus 3 plus 4 divided by 3. So 2 plus 3 is 5, 5 plus 4 is 9, 9 divided by 3 is 3. But if you try to see here, the answer is coming out to be only here 2. So what is this happening? That is my question to you all. Now, on the other hand, if you try to use here the C command, then if you try to find out the same command here, mean, then it is giving you the value 3, which is matching with your manual calculation. So this actually value is wrong and this is here correct. But now my question is that in these two cases, maximum and minimum, there was no problem. But in the case of mean, if you are using C, then it is giving you the correct answer. If you are not using C, then it is giving you a wrong answer. So what is correct, what to do and what not to do? And in case if you try to see the repercussions of this operation, so can you think about it? What will happen with these things? So whenever we are trying to do some bigger programming, right? In the bigger programming, actually what happens that there are many steps. And it is possible. It means if you try to think about a very simple condition that suppose you are writing a bigger program. And in which in that program at one step you have given the means you are trying to compute the mean of certain values, and this value is then going to be used in the next step as an input. Right. So now when you are trying to execute this program, and if you are not using here the C, it will give you some value. This value is going to be fed in the next step. And after that, you will get an outcome. There will be no warning, no error. But at the end of the day, you will means all those calculations are going to be wrong because they are going to give you a wrong outcome. So, and then you will actually come to know. So, but now you have understood that when you are trying to give the C command, then at least you are getting the correct value. So now there are two options, that why this is happening and what is the solution. The solution is the solution, and my advice to you all is that you simply always try to use the C command without exception, because at least when you are trying to use the C command to give this input, then at least there is no chance of making a mistake. Whereas when you are not using this C command, then there is a good chance of making a mistake. So now onwards, there should be a very simple rule that whenever you want to use more than one values, use the C command to combine them. Now, the next question comes that why this is happening. I don't know the exact reason, but if I try to think about it, it might be possible that when this R software started, then actually that was not a one company or a couple of people who are working, but different people across the world from different academic institutions, they got associated with this thing. Right. For example, I know that in Europe, a couple of people were there. For example, I know one of the person in the Department of Statistics at University of Munich, where I used to visit. He was there and he got the job there because he was associated with this art project. So that was a very great thing. So he has also developed some this algorithm for generating the random numbers from the normal distribution. So what was happening that at that time somebody was sitting in Germany, somebody in UK, somebody in India or somewhere in different parts of the world, and they were assigned different jobs. Okay, you please develop a program for mean, you do it for standard deviation and so on. It might be possible that someone developed the program by using the command C and somebody cannot use the command C. So that is why possibly this thing is coming. So, but now means whether you try to how to take care of this, that I don't know. But as a user, I would suggest you that you always try to use the C command. Right. So now I have shown you here two aspects. I have shown you about minimum, maximum, and mean command, and simultaneously I have shown you how you can use them. So you simply have to write the program, and within the parentheses you have to give the data vector. Right. So similar to these commands, there are many other options which you can use. This is ABS for absolute values, SQRT for finding out the square root, round, floor, ceiling, sum. They are for rounding in a different way. You know that how you can round off these numbers. Similarly, here sum, product, log, then log base 10, log base 2, exponential function, trigonometry function, hyperbolic trigonometry function. All are possible. So let me try to take here some example and try to show you that how do they work. For example, if you want to find out the absolute value of a number, say -4, then if you write here ABS inside this parenthesis, you write -4, and then it will become here 4. And similarly, if you try to take here a data vector also, then you can see here that this absolute is going to be operated on each of this value here. And absolute value of -1 is 1, -2 is 2, -3 is 3, and absolute value of 4 and 5 is the same as 4 and 5. So you can see here that these functions, they are working on individual values as well as on the vector values also, and they try to operate on the individual values, right? Similarly, if you try to take here the function of SQRT, so you can see here that square root of 4 is 2. But if you try to take here a data vector, 4, 9, 16, 25, so the square root function will come inside. This will be square root of 4, square root of 9, square root of 16, and square root of 25, which will become here 2, 3, 4, and 5. So once again, you can see here this is happening. Now, what will happen if you try to take a negative number? You can try, and it will not give you any answer. Right. Similarly, you have here a function here, sum and product. So sum is used to find out the sum of the number which are given inside the parenthesis. So you can see here you are trying to give this data vector 2, 3, 5, 7. So it is trying to give the value of 2 plus 3 plus 5 plus 7. And similarly here product PROD, that is going to give you the values of the product of the four numbers 2 into 3 into 5 into 7. Right. So that is how it is going to actually work. So now you can see here that if you are trying to do some statistical programming, etc., it becomes very simple. Suppose, let me try to show you here one example. Those who know a little bit of statistics, they know that we have a very popular quantity like summation xi minus x bar whole square. So if you try to find out here, so yeah, if you want to here write down here directly here, so this is going to be here sum of say here data vector x minus mean of x and then hat 2. That's all. And even if you try to expand it, and it is like the summation xi square minus n times x bar square. So this will become here sum of here x hat 2. Minus say here n, actually n is the number of elements in the data vector x. So for that we have the command here length of n into say mean of x and then whole square. Right. So you can see here these types of commands can be written here very easily. And as a statistician, I'm doing all my programming in the R software and it really helps, I'm telling you. And yes, so whatever now I have given you the operations in different ways. They are between scalar, vector, or say data scalar, or say state layer vector. Right. But now I want to tell you here that even you can take their combinations also. You can take these functions, built-in functions, and then you can take the data vector or the scalars also. For example, if you try to see here, I'm trying to take here C1, 2, 3, 4. Now I'm trying to take here this function sum of C1, 2, 3, 4, and then product of C1, 2. So what will happen here? Because these things are inside the parentheses. Can you see me or not? Can you see the slides? Because something happened. Hello?
It's visible, sir. You carry on.
Achha, okay, because something happened and I couldn't understand whether the connection is lost. Right. Anyway, so if you try to see here, this is here like this product of C1, 2. So 1 into 2 is going to be here 2. Now this 2 into this star, it is going to be multiplied over all these elements. And then it is whatever is this here 2 into means here 2 and then here 4, then 6 and then 8. Then it is their sum and then it will be added here. So you can see here that combination of scalar data vectors and built-in function, this all is possible without any problem. Right. Right. So now first you tell me, do you have any doubts or question up to this point? Because this is quite a different way in which this actually our software actually works. So do you have any doubts or question?
Sir, in Excel also.
Yes.
Sorry, the echo sound is coming. Am I audible, sir?
Yes, yes, sure.
But some echo sound is coming from. Okay.
It is not from me, at least I can't control it. I think some of you, I think all of you can actually unmute, and then those who are speaking, they can unmute. So that will help.
Sir, if I have a big data set also available with me, in if I filter in Excel sheet also,
Yes.
there is formalized the mean, media, mode, average. Then
Yes.
how is the whatever the benefit for the R, sir? even everything is available in Excel. So what could be more benefits so the peoples or industries more recommending for our? Is there any specific or very easy method is available, sir?
Yes, okay. Okay, I will come back a little bit, means little bit earlier than to your question. Suppose I am the director or CEO of your company, right? And suppose I give this option to you that okay, without doing this, using this software, definitely you can't work, you can't do the modeling, you cannot compute the things. But now I am giving you here two options. That first option is this: you can buy MS Excel and all those things. There is no issue. There is no scarcity of the funds. And the second option is this: if you don't buy this software, whatever is the cost of those softwares, I am going to add in the salaries of all the employees. So if you are working, if if you are spending say 1 lakh of rupees means every month on the software, then if you start using the free software, then I will distribute this 1 lakh of rupees equally among all the employees, those who are using the software. What will be your choice?
It is okay. This is all about the economy.
Right, right. So the first thing is actually this cost part. Because you are working in the industry, so you can afford it. But if you come to my IIT, there are many students, if you ask them to buy it, they cannot. Even if you ask ourselves that how many of us have really purchased the MS Office software up to now? If you ask me, yes, I have done it because of technical reason, because whenever we are trying to compile any report, etc., then now there is a legal because they can always ask me from where you have bought this software, and I can share with you, and then I will come to your answer also. That it happened, I will not tell you the name, but at one of the IITs, it happened that there was some problem among the colleagues, and then what in IITs in somewhere I know, means I heard this story that there was some problem among the colleagues, and then somebody complained, and then Microsoft had written that okay, from where you have typed this document. He said, yeah, in this MS Office, something like this. Then he said, okay, when you bought it. And then, believe me, I have heard, and this is possibly the true story, that it was difficult for him to save his job. That is the first thing. So that is advisable to all of us, that now whenever we are trying to do the research, we have to do the computations, we have to do the calculations, and they are going to be published in some journals on some websites. So we have to be very clear in informing everyone that how I have done the calculation, number two. Number three, now I come to your more specific pinpointed reply that you see in MS Excel, in case if I want to do any programming, I cannot do it. Right, surely I can find out here a command like mean of x whole square, that I can do it here. Yeah, there is no doubt about it. But if you try to think when you are trying to write down a program of yourself, and you are getting the data from some time series model, and then whatever outcome is coming here, you are trying to fit it into a logistic regression, and then you are trying to calculate that whether the credit card has to be given to someone or not. For example, you can see from the trend that there is a customer who was always fluctuating in his income, monthly income. So in January, it was say 1 lakh, in February, it was 40,000, in February, it was 20,000, then in March, it was 0, then in February, then in April, it became say here 0, then in May, it was say 20,000 and so on. So in this case, there is a trend that one has to determine that whether this person has to be given the credit card or not, because the credit card company has to be confident that this person is capable of repaying the loan. So now this data is fed to a time series model, and then the outcome comes over here, and then you are going to use the logistic regression model to see whether what is the probability that if this person is given the credit card, he or she is going to refund the money in time. So now you want to input that data into the logistic regression, where the outcome is going to be in terms of 0 and 1, where your dependent variable is 0, 1. So now how will you do it in the this is MS Excel, number 1. In MS Excel, with my limited knowledge, possibly there is a possibility, because there is statistical function also. So it is possible that you may obtain the time series model, or you may obtain the logistic regression model, which is built in only. Right, but if you want to modify it, if you ask us, whenever our students are doing a project, we always say that you don't have to do what is there in the package, but you have to do something new. How are you going to do? So for simple people, those who want to do a quick solution, these things can work well. But if you ask us as a student, as a programmer, where we are trying to do something new, it will not work at all. We are practically handicapped actually. So that is the first thing. Third thing is this, I can share with you, which is more practical. Suppose you have a company which has got suppose 20 branches all over the country, and you simply want to see the monthly expenses by the male and female. And you simply write a program, and simply you ask Miss everyone to give you to send you the say some graphic. Now somebody uses the blue for male and green for female. Somebody uses red for male, blue for female, and so on. Now you are getting 20 graphics. Can you really compare it? They are different sizes, different labels, etc. But in the R, you can simply just write a small program, and you simply ask them, OK, whatever is your data, just execute it. Whatever is the outcome, you send it to me. Now all the graphics are going to be uniform, which is possibly not possible in the R software. And then secondly, in this case, you can simply write a small script, a small function that you can circulate to all the branches, and you simply try to tell them, OK, you are getting the data, no issues. You simply trying to execute this program, and whatever is the report files, send it to me. So that way it is going to help us. And believe me, at this stage, if you name any big company, they have switched to this R software. Because if you try to look into the Google, the cost of SPSS and other software, it is not an easy job. It comes in millions. So unless and until somebody is trying to buy this software, now companies are not using this software. It is as simple as that. I'm telling you, I'm conducting the training program for the Government of India. And recently we have conducted a project for the Ministry of Defense and the Prime Minister's office. The first condition was you are not going to use any software which has a recurring cost. So now we have to base it on the Python and R software and other free softwares only. So that is the condition. So these are there are many situations now in which nowadays people are not people don't want to do these things. So these are my couple of replies which I have gathered from my experience. So do you think that any other reason can be there?
No, sir. Thank you, sir. Thanks for explanation.
So now I come to the aspect of matrices. So matrices, actually, because Anuradha told me that this is going to be an advanced program actually. So whenever you are trying to use any built-in statistical tool, the input data can be given in the form of scalars, data vectors, and matrices. So that is why I have given you this scalars and data vector for the quick revision. Similarly, I will go with the matrix also, because the input and output of the program can be in the matrix format also. So matrix, matrix most of us have studied in our graduation. This is a sort of collection of elements where means every element has got a particular address in terms of rows and columns. Right. So and then if you really want to call any element, you can just call that element by the rows and column also. So this matrix is essentially a rectangular array which has got suppose p number of rows and n number of columns. And in the book style, we try to denote the symbol by its like is an xij, and in the program version usually it is like an x, and inside the square bracket this is I comma j. So there are here suppose here n rows, so this is I goes from 1 to n, and there are here p columns, so j goes from here say p columns over here. Yeah, and then ing you can, yeah. So now the elements in this matrix, yeah, that can be a number, that can be a string character also. But when we are trying to deal with the mathematical thing, all the elements are going to be only the numbers, numericals. So the first question comes here, how are you going to create a matrix and how you can make different types of manipulations on this matrix? So suppose I want to create here a matrix of order 4 by 2. That means there are 4 rows and 2 columns. And the data is going to be here like this. Suppose here 1, 2, 3, 4, 5, 6, 7, 8. So now in order to create the matrix here, you need here 3 types of information: that how many number of rows, how many number of columns, and what is the indicator, that what you want inside the matrix. And then, yeah, when you are trying to talk about the data, then you also have to tell that how the data is going to be arranged inside the matrix. So for that, we have a command here, matrix matrix. So and then there are actually many parameters, but I will be describing only the three essential parameters which are going to help us. So first here is n row. NROW, that means the number of rows, that how many number of rows you would like to have in the matrix. And then it is here ncol, that how many elements, sorry, how many columns you want to add it in the matrix. And then there are 4 rows, 2 columns, so total number of elements are going to be 4 into 2, which is equal to here 8. So what are those 8 values that you want to enter? So this I give it by here the command here dat data, and then I try to give here suppose 8 values just for the sake of understanding, numbers 1 to 8, like here this. So you can see here, then you will get here this type of outcome. Yeah, and this is here the screenshot. So you can see here, these are my here 2 columns, column 1, column 2. These are my here 4 rows, 1, 2, 3, 4, and the data is entered like this: 1, 2, 2, 2 to 3, 3 to 4, then 4 to 5, 5 to 6, 6 to 7, 7 to 8. So you can see here data is coming here in the like this column wise. Right. So that is the default way in which the data is going to be arranged in this one. Right, so in this case, you can see here that if you have used here n row and column data, so this n row defines the number of rows, and col defines number of columns, and data assigns the values. Now, in this matrix here, if you really want to call any particular element, then how can you do it? Suppose this is your here X matrix. Suppose you want to call the element in the third row and second column, which is here like this. So what you have to do here, you simply have to write down the name of the matrix object here X, and then inside the square brackets. Now you can see here that the square brackets are used to assign the location in the matrix. Then you try to write down here X, and then here row number, and then here column number. Right. So now whatever is your row number 3, column number here 2, you try to give it, and it will give you here this particular value here 7. Right. So this is how you can access a particular element of a matrix by giving the rows and columns. OK, now if you try to see in this case, what I shown you here, that the data is going to be entered in the column wise format. Now suppose I have to enter it in the row wise, then what will happen? Right. So if you try to see here, this is the command which I had used earlier. So if you try to add here the command here by row. So by row is the parameter which controls the fact that whether the data is to be entered row wise or say column wise. So now, and this by row is this is a logical operator. Logical operator means the answers are going to be in terms of true or false. So when you are trying to say here by row is equal to here false, that means the rows that the data is not to be arranged row wise. So if the data is not to be arranged by row wise, what is the option? The data is going to be arranged only by the column wise. So and that is what happened, that this is the default. So you can see here in this case, the data will come out to be 1 to 2, 2 to 3, 3 to 4, 4 to 5, then 6, then 7, and then 8. So this is column wise like this. Right. And this is the same thing what you used here in this command. So by row equal to false is the default, which is you have to keep in mind. Now, if you want to arrange the data to be row wise, then you have to make it here by row equal to true. Right. So in this case, you will see here, n row is the same 4, n call is the 2 same, and data is the same here as 8 values. But now the data is going to be like this: 1 to 2, 2 to 3, 3 to 4, 4 to 5, then 6, then 7, and then 8. Right. So this is how we can control the entry of the data in the matrix, whether it has to be row wise or column wise. OK. So, and then you can see here, this is here the outcome. If you try to see here, this is the by row equal to true, which is this, sorry, by row equal to false, which is the default. And this is here with the command by row equal to here true. You can see here the data is arranged like this column wise, and here the data is arranged row wise like this. Right. So this is how you can enter your data. So now look, let me try to first consider the same thing. So I have here this matrix here X. Now I try to make here different types of operations on this thing. So you see one operation here is transpose. What do you do in the transpose? That the rows and columns are going to be interchanged. That rows will become column and column will become rows. So for that, we have an operation over here. So you can see here, if you want to see, this is your here this matrix, and if you want to have it transpose, then the first row will become here first column, second row will become here second column, third row will become here third column, and fourth row will become here fourth column like this. So to this operation, we have a command here T. So if you try to write down here T and within the parentheses X, then it is going to give you the transpose of the matrix. And yeah, means transpose is a very important thing when we are trying to do with the matrix manipulations. And now I come to the aspect here that what will really happen if you try to means how are you going to do different types of matrix manipulations and how it actually works. So you know that when we are trying to talk about the matrix theory, then the rules for the matrix manipulation, they are quite different than the rules for the usual non-matrix calculations. So how to get them done and how they are going to work. This is I want to give you here a brief review. So if I try to take here the same matrix here X with these elements here like this. So now if I try to add here one scalar, you can see here, this is a scalar and this X here is a matrix. So when you are trying to add here a scalar, then what is happening? You can see here 5 is being added to each of the element in this matrix. Right, you can see here now. This is the output. 5 plus 1, 6, 2 plus 5, 7, and so on. And this is here the screenshot of the same operation. So you can see here in this each of this element, this is added by 5. This gives you here this thing. Right. And similarly, if you want to subtract it, the similar operation will happen, that each of this element in the matrix X, which is going to be subtracted by 5. So this will become 1 minus 5, 3 minus 5, 5 minus 5, 7 minus 5, and so on. 2 minus 5, 4 minus 5, 6 minus 5, 8 minus 5. And we get here this type of operation. So the rule is that when you are trying to add or subtract a scalar in the matrix, and the same thing is true for addition and division also, sorry, multiplication and division also, then that scalar is going to operate on each of the element in the matrix. Right, so because if you try to see here in the same operation, I try to make it here x divided by 2. So this will become here 1 by 2, 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, and 8 by 2. Right, so that is going to happen here. And so, and now I want to give you here the addition subtraction when you are trying to take two matrices. So this was all about, and then yeah, same thing will happen with the multiplication also. If you try to take here the same matrix, and if you try to multiply it by some scalar, then that number is going to multiply each and every element in the matrix. Okay. So now I try to give you here the operations when we are trying to do with the matrices, between the matrices, among the matrices. So I try to, so you know that when you want to do the addition and subtraction in the matrix, then the two, then each of the two matrices, they have to have the same order. Right, so I try to do here like this. I try to create here two matrices X and Y of the same order, 4 by 2. And in the X matrix, I take the data 1, 2, 3, 4, 5, 6, 7, 8. Actually, yeah, means if you want to write here 1 colon 8, so that is the indication, or that is the command that the data from 1 to 8 is going to be there at an equal width. And similarly, if you want to write down here, if you write here 11 colon 18, then the data is going to be 11, 12, 13, 14, 15, 16, 17, 18. So I try to create here these two matrices X and Y. So you can see here, this is the same command which I used earlier, that matrix, then n row, n col, and data. So you get here these two matrices. So both are here 4 by 2 matrices. So if I try to add here, so you know that when you are trying to add or subtract, then the addition subtraction between the two matrices is happening the element wise. That means whatever is the address of this number on the first row and first column, that is going to operate with another matrices number which is located at the same address, that is the first row and first column. Similarly, if you try to take here 6, so 6 is on the third row, second column. So whatever is the number in the third row and second column, this is going to be operated when we are trying to, and this addition and multiplication, sorry, addition and subtraction. So similarly, if you try to see here, x plus y, so x is here like this, y here is like this, 1 plus 11, this is here 12. Then similarly, if you try to take the last one, see here 8 plus 18, that is here 26. Right, and if you try to subtract it, the same thing will happen here. Say 1, this one minus 11, which is here minus 10. Right, and similarly, if you try to take here, say here this element on the fourth row, first column 7. Similarly, with the fourth row and first column in the second data vector 17, 7 minus 17, which is here minus 10, and so on. So you can see here that addition and subtraction, they are not difficult, and you can do them without any problem. Okay, right. You can see here, yeah, this is the same slide actually. Now, when you try to do the multiplication, so you know that when we are talking of the multiplication of matrices, then the rules are going to be quite different, right? So for example, the first rule is if you have here two matrices X and Y, then if the order of the first matrix is m cross n, then the Y has to be n cross something p or whatever you want. So the condition is that the number of columns in the first matrix and the number of rows in the second matrix, they should actually match, right? So if you try to, so following that rule, if I try to create the two matrices here, X and Y here like this, so number of rows in the X I'm taking here 4, 2, and the number of rows and columns in the Y I'm taking here 2 and 4. So this will become here 4 by 2 and then here 2 by 4. So now this 2 and 2 is matching, so they can be multiplied together. So X here is 1, 2, 3, 4, 5, 6, 7, 8, and then now this is here. Here there are 2 rows and 4 columns. Now, if you want to do the matrix multiplication, then it is here like this. The sign here is percentage star percentage. Right. And I want you to be here watchful and careful that if you are trying to use only star, then the element then the address wise multiplication is going to happen. For example, if you try to take here this example, and if you simply try to write down here X star Y, so this 1 and this 11, they are going to be multiplied. Simply this here 8 and 18, they are going to be multiplied. So be careful that when you are trying to use the uh, um, this matrix multiplication. For example, in this case, if you want to multiply this X and Y, which are square matrices, then you will not even come to know that what mistake you are trying to make. You will get some answer, but that answer won't be correct. So be very careful when you are trying to do the matrix multiplication application. So you can see here when I try to multiply X into Y. So X here is 4 by 2. Y here is 2 by 4. So now this 2 and 2, they are the same. So you are getting here an outcome of order 4 by 4, like here, like this one. And similarly, if you try to multiply here Y and X, so Y here is 2 by 4 and X here is 4 by 2. So now this is here 2 by 2. Right, so this is how the matrix multiplication actually works. Yeah, how to do the matrix multiplication, that is an entirely different thing, and I believe you know it. And now I want to give you here one more example. Suppose I try to obtain the product like of two matrices like X transpose X. Right. So it can be written very simply by here transpose of X and then percentage star percentage X. Right. So now you can see here what will happen here. This is your here X, which is a 4 by 2 matrix, and the data is arranged row wise like here this. And then I try to take its transpose, then this is here like this. The rows and columns are interchanged. And if I want to find out here their say X transpose X, then I can write down here like this. This will give me this answer. And if you want to find out X transpose, I can write down in this particular, there is no issue. But what I want to tell you here, that if you want to find out this X transpose X, then there is a command here, cross prod, CROSSPROD. Actually, this will also give you the same thing. If you simply write down here cross prod X, then it will simply try to give you the here X transpose here X. Right. Now the question comes here. Means I can show you. This is here X. This is transpose of X, and this is, if you try to see here, this is product of X, and this I'm trying to show you here on the screenshot that this both the answers are going to be the same. Right. So the question comes here, why should I use this thing? So the answer is very simple. When you are trying to use the matrix operation, particularly when your matrices size are quite big, right, then this prod function will give you the results faster. When you are trying to do for 2 by 2, 3 by 3 matrix, that will not actually make any difference. But when we are trying to deal in the real life, then somehow the order of the matrices are quite high. Then in that case, this cross prod works very well. And in statistics, finding out this X transpose X, this is a very important quantity. You will see in my fourth lecture that when we are going to talk about the linear regression analysis, then we are going to use this thing over there. Now, similarly, if you want to find out the inverse of the matrix here, then for that we have command here solve. right? Solve, you know why? Because in many software it is actually INV, but here it is solve, and it is more logical because when you want to find out the inverse of a matrix, those who are from the mathematical side, they will know that they want to solve these equations, and then it gives you the value of the inverse of a matrix. So, but in any way, this is out of the range to discuss those things. But here the command here is solve, and then there are some conditions for the inverse of the matrices, like it has to be positive, definite, full rank matrix, etc. So if those conditions are satisfied, then the inverse will be found. For example, you can see here, if I try to take here a matrix of order, say 2 by 2 only, like which has here 4 values, like 84, 100, and 120, like this one. Then if I try to use here solve of y, then it will give me the inverse of order 2 by 2, right? So now I would like to show you here a couple of things on the R console actually, which is more easier for me to explain. Wait. Yes. So yeah, just give me a minute so that I can just do it. I try to take this matrix over here and let me stop sharing, and then I come to this here R console actually here. Right, so now you can see my here, this R window. I will increase the font size so that you can see it more clearly. Right. If I try to create here this matrix here X, right. So now you can see here it is here like this. And if you want to get here is any particular value here, say X 2,3, you can see here it is not giving you. Why? Because there are only actually 2 columns actually. So let me try to write down 2, 1. So that is going to give you here the value here 3. Okay, can you see this screen or not?
It's visible, sir.
Okay, sure. Okay. So if you try to see here, if you try to take here X 2, 1, this is here 3. Now I want to show you here a couple of things where you have to be very watchful. Suppose I want to extract a particular row, then how to give it? So the rule I'm telling you is very simple. Try to write down here the name of the data object, what you have created, and then whatever row or column you want to give, you just try to give here like this. So suppose if I want to give it here like this, say 2, comma like this. We'll get here the values in the second row. And similarly, if you try to want here in the value in the second column, then you have to give it comma and then 2. So if you try to see what I have done, I simply have copied this address because usually there is a confusion now where to give the blank sign. At the first place or in the second place. So I will say simply try to see how this R is going to define your matrix here X and try to just copy and paste the same command over here. Now, my my confusion is like this. Suppose I show you only this thing. Yes. Now 2, 4, 6, 8. Can you identify that whether this is a row vector or a column vector, whether this is the value of a particular row or a particular column? No, this is not possible. Because if you try to see here, actually what really happens that in some of the software, when you are trying to print this type of thing, then they will try to give you here like this, say comma 2 or 2 comma. So from there you can identify whether the outcome is a row vector or a column vector, but here it is not possible. Right. So this is what you have to see that if you want to extract anything here, you can do in this particular way, or you can extract the row, column, etc. And also, I will show you here. This is your here X. You can also extract a submatrix from here. For example, if I want to have here a matrix having third and fourth rows, and here one and the first and second column. Sorry. This will be here like this. So I'm trying to take here third and fourth row, and then here first and second column. So you get here this matrix. On the other hand, if you really want to choose some other values here, like as say this the second and fourth row, so I can use here the C command 2 comma here 4. And then if I want to, yeah, here you don't have any option. But anyway, if you have more than any support. Yeah, when somebody had joined. Okay. So you can see here, if I say here 1 comma 2, then you can see here like this. Right. So that is how you can see here now that how the things are going to work now here. So in this way, you can extract any row, column, submatrix, etc., and it is not going to be different here. Right. So I think let me stop here, and then yeah, because this matrix theory is quite huge here, and yeah. So, but then I have just to give you the basic idea that when you are trying to enter the data or you want to read the data from somewhere, how are you going to work on it? So yeah. So if you have any question, you can ask. And then, yeah, in fact, well, I have taken here very basic, simple operation. Even if you want to do some higher level computation, like Miss eigenvalues and some like matrix decomposition, etc., everything is possible here. The best thing is that before operating it, try to look into the help menu that how you have to give the data in such a way. I think you can just unmute, means unless until you want to ask anything.
Sir, one question. I still did not get kind of much clarity on that multiplication part, wherein you used x star x and then x modulo star and modulo.
Okay, that one. Okay.
Yeah.
Means x. Okay, x is okay. I will show you. I will just share my screen. So let me try to create here two matrices here. Suppose I create here Y matrix here, and then suppose its values are say 11 to 18. Now you can see here I have here X and I have here Y. Right. Now if I try to give here X star Y, you will see here what will happen. These elements wise things will happen. For example, this one is in the first row, first column. That is going to be multiplied by the element in the Y, which is at the first row and first column. Right. And similarly, if you try to see here the last value, that is the fourth row, second column, that is going to be multiplied with the value in the fourth row and second column. So this matrix multiplication is happening element wise. Right. Whereas if you try to see when you are trying to do the matrix multiplication, Matrix multiplication is a very different thing that rows are going to be multiplied with the corresponding elements of those things. For example, if you try to give here, suppose if I try to give here X transpose, see here star here and here Y, you will see that it will actually not actually work, because multiplication has to be defined in such a way such that the number of columns in the first matrix and the number of rows in the second matrix, they should be the same. For example, if I try to write down here, instead of like this, if I try to write down here trace of Y, then you will see here this is coming here, and now you can see here this X star Y and this matrix multiplication, these are two entirely different things. So that is what I was saying, that sometimes people get confused that and they will simply trying to use X star Y. So that will give them the value, but it is not going to be the correct. Particularly, actually, this thing will happen when you have the square matrix of X and Y, because in the square matrix, this order is not a problem. If you are trying to take some rectangular matrix, then program will say error. But anyway, so that you have to be careful. That is what I was trying to share from my experience, that what are the common mistakes which people are trying to make.
Got it, sir. Thank you.
Jenny. Right, anything else? No, okay. So I think so. But stop this question then, if they don't have any questions.
If any participant don't have any question, then I think we should conclude the session.
And after this, if you want to actually, you see, I have taken very elementary operation, which I was telling, but when you are trying to do this advanced level courses in statistics, then at many places you will need some other type of matrix operation. For example, if I say Moore-Penrose inverse, generalized inverse, that even the matrix are not of a square matrix, they are rectangular matrix, even then you can find out the inverse. So for those things, you have the options for finding out the Moore-Penrose inverse, Cayley-Hamilton theorem, finding out the characteristic rule, characteristic vector, everything is available over there.
Sir.
Yes.
There is one question from one participant. Can we do numerical calculations on tensors?
Yes. Why not? The only thing is this, you have to just look for the appropriate package which can help you and that will help you in avoiding the calculation. Otherwise, you can always write your own functions and can do it.
Okay, another question is, means there was a question that is there any concept of array in R? So
yes,
I said
actually,
yes, you can.
actually that is array. Actually, what I said, that is the mathematical array. Otherwise, yeah, means arrays are there. Data frame that I am going to take tomorrow. That's an array actually. So array is simply the arrangement of the values in rows and columns. So the difference between matrices and array is that in matrix, all the elements are going to be only numerical values such that mathematical operations can be done. But in the case of array, the entries can be character or can be numerical. So tomorrow when we are trying to do with the data frame, possibly we will talk about it.
Okay, so JBL, sir, your answer is there that when we discuss about data frames, that would be heterogeneous type of data where we can put integer and character simultaneously in the array. Okay. Another question is R more powerful than Python, or are these both the same? This is a multi-dollar question.
Yeah, no. Actually, you could see, this is only a matter of time. When I joined here, at IT Kanpur, or when I joined my job 25 years back, then head used to be head, or with any administrative position used to be a very strong position. But now after 25 years, I don't care, because I myself is there and I don't, isme kya rakha hai. That's a very simple thing. So, but that was on a lighter side. The fact is this, you see, R and Python, these are two different different things. Or if I try to retranslate your question in a very simple way, you have suppose two shirts. One is some white or sky blue plain, and another is some red with some golden work on it. So what do you think, which shirt is better? My answer will be, if I am going to a class, then possibly a white or sky blue shirt will be a better option. But if I am going to my friend's marriage, then possibly that red with golden embroidery will be a better option. So now what do you say, which shirt is better? So the similar is the answer to your question also. This R and Python, both are doing a similar job. It all depends that what type of job you are trying to do. For example, if you are trying to deal with big data sets, for example, big data set doesn't mean your GB or TB, they are in petabytes. So then I don't know, but I have read that then this Python becomes more efficient. And similarly, if you are trying to do this management of data only, that you want to generate different types of queries. For example, you have a big data set and you want to know that how many students they are male and they have got more than 30 marks in mathematics, but less than 50 marks in chemistry, etc. These type of queries which are related to the database management system, possibly Python is better. And but when you are trying to do statistical modeling, then yeah, means the number of statistical tools, statistical package which are available in the R software, possibly they are much more than what they are available in the Python. But if you are going for this elementary operations only in statistics also, then means I know I've not used it, but these tools are available in both the cases. For example, if you want to find out mean, median, mode, or you want to draw pie chart, histogram, etc., then either you are using Python or say R, then it will not make any difference. But one confusion that I would like to clear here, many people, this R started in I think late 90s, right? And then suddenly people talking started about Python in the last 8 to 10 years. So many people think that Python was invented in 20s. The fact is this Python was invented in 1970s. But that was the bad luck that it didn't got so much of fame. But this Python language is right there for the last 40, 50 years. But somehow when we started dealing with the bigger data sets, because now the data sets are actually created by our this automated system. For example, your cell phone is sending lots of data every second to the Google server. So means you can imagine that all over the people all over the world, if they are using the cell phone, then how much data is being collected every microsecond on the Google server. So when we are trying to deal with that type of data sets, I have heard that this Python works better. But then I'm not saying that R doesn't work. So my advice will be that instead of getting into the conflict, whether R is better or Python is better, try to learn both. Right, and because you can see many documents, they are unnecessarily trying to create a confusion among the people that, okay, this year in 2020, there were 5 million people using R and there were 6 million people using Python. Somebody says this is simply garbage. You are a teacher, you are a student, you have to use it. Just try to use what you want to say. Tell me one thing, whether PGI Chandigarh is better or PGI Lucknow is better. It all depends on the patient, that whose expertise is there in which of the hospital. So instead of getting this confusion, better is to learn both the things. That is only a matter of 1 week for R and 1 week for Python.
Okay, I am not able to see any more questions. If there are more questions, then please ask. Otherwise, we can end up the session now. And sir, tomorrow's session, at what time will it begin? 9 o'clock?
9 o'clock, yeah.
Okay, and 9 o'clock from sir's side means 9 o'clock.
Yeah, means actually I can share with you. And actually, I always prefer to conduct the physical workshops at IT Kanpur. That when people come here, they try to learn a very different type of culture. For example, our here time is suppose 8 to 8:50 and then 10 minutes break and then 9 to 9:50. 8 means I will start writing on the blackboard at 8:00. And I will try to reach outside my class at least 5 minutes before, so that when I'm entering, I'm not, not like this. 8 means class should start at 8 o'clock. We try our best to finish at 8:50 because the students have to go for the next class. It can be 8:51 otherwise. We have to start. We have to start, and when we go in the class, right. So means 8 means whether it is director or say any dean, whatsoever. I am means looking after many responsibilities, but then I will take my classes at my time. Whatsoever happens, even if the director calls me for a meeting and I have a class, I have a full liberty to say, sir, I have a class, I will come after that. Many people, many institutes, many universities, I say, if the director calls, it becomes like a पता नहीं किसने कॉल कर लिया तो उनके लिए क्लास इंपॉर्टेंट नहीं होती है. फॉर मी द क्लास इज मोस्ट इंपॉर्टेंट थिंग एंड इफ यू ट्राई टू अंडरस्टैंड I can give this answer very simply. Try to think the student in your class is your own child, own son or own daughter. The answers will come very clearly to you. Nobody will argue after this, because if the teacher of your son or daughter comes 5 minutes late, many times I have seen in the parent-teacher meeting people argue. But when we are trying to do it at ourselves, we don't believe. And मुझको ये पता है कि God has given me the limited time. और जब अंत समय आएगा तो भगवान मुझको 1 सेकंड एक्स्ट्रा नहीं देगा. So why to waste this time and try to work here, for which we are here. जिस तरीके से हम कुछ गलत काम नहीं करते हैं, तो अगर मुझको सैलरी मिल रही है, I have to justify it. And I have to justify for every second. I always give a counter example. Suppose if inside the class, if there is a rule that I will be paid, say, suppose 100 rupees per second, then I will see that how many teachers enter into their classroom late, 1 second late. Right. So if somebody is trying to be good with us, government is trying to be good with us without taking any attendance, they are giving us full salary. So we should be honest to ourselves. That actually, so it's not an instruction, that's my habit. Right. And then, yeah, means habit means your habit up to 4:20 I was in my office. Then I said, okay, it is going to be 6. So then why my staff should wait? So I left at 4:20. Within 5 minutes, I was at home. And then I started my session here. So that is my practice. And if you talk to any of the faculty over here, they are like this. And if you have any doubt, if you want to contradict, this is bad, I am open to criticism. So that is the only thing. So I am, yeah. And then it's not that I'm from IT. I have a background which means I'm a student of Lucknow University. I have been taught in the university system. I have taught in the university system, but I will say only one thing, that there are some teachers who have taught me what are do's, and there are some teachers who have taught me don'ts. They have taught me don't do these things in my life. There were teachers who were coming late inside the classroom. They have taught me that how it feels when somebody is coming late to my inside the class. Sometimes there can be something very extreme one can imagine. But in the normal days, why? So that is very simple thing, and that really irritates actually, because once you are teaching, for example, I was teaching, suddenly this window was going back, and then this screen will pop up. So after some time, you lose your actually this concentration actually. Actually, that was the reason that I was unable to go through with the R software live demonstration, because the screen was flickering so much that it was even difficult for me to concentrate. Because whatever is written, whatever are your slides, you can see I am empty-handed, nothing is around me. So whatever God gives me that signal, I try to speak. So yeah, so that was the reason. So don't take it at a personal level. But if anybody has a doubt, it means we can talk about it, whether coming to class in time is right or wrong. And then secondly, I say the government has given us lots of money for this workshop. This money is not coming from the government. We are paying it from our pocket. Means every month 35%, 40% tax is deducted. Right. So means if you are coming to the same workshop for 5 times, if government gives us an option that, okay, I can lower your income tax by 30%, then what's wrong? So these are the very simple thing which we have to think, that's all, nothing more than that. Right, Anuradha, then we take care.
Yes, sir. Okay,
right.
We'll meet tomorrow at 9 a.m. sharp.
Right.
Okay, thank you so much, sir.
Right.
Thank you so much, participants, and please don't worry, I will take the attendance from the teams. Please don't ask me questions for attendance. I will take from the teams. We have the option to download attendance participant list over here. Okay, thank you so much. And tomorrow we'll have 3 sessions. One is from 9 o'clock, the 9 to 11. The other one is from 11:30. And the third one is post lunch. First session is 9 to 11. Second is, second one is 2 o'clock to 4 o'clock. And then we have from 4:30 to 6:20. Sorry, there is slight change. 9 to 11, 2 to 4, 4:30 to 6:20. And these changes are only for tomorrow because Shalabh sir is quite busy. Rest 3 days we will have from 9:30 to 4:30 only. Okay. Thank you so much everyone for joining.